Good day to all of you. Today we shall discuss on basic processing unit. That is the basic processing unit of a computer. That is processor. Our sincere acknowledgement and thanks to Carl Hamacher, author of the textbook Computer Organization, 5th edition. The content of whole discussion I have taken from this textbook. To discuss this, we need this diagram, that is single bus organization of data path inside a processor. So data path in the sense ALU and different registers and the internal bus connecting these. Hence we shall have some brief discussion on the different registers present in the processor and ALU. So R0 to Rn-1 are the general purpose registers present in a processor. The number of general purpose registers vary from processor to processor. They are used for temporary storage of data during execution. There are some special registers other than these general purpose registers inside the processor. So the first one, program counter, that is PC. This register always stores the address of next instruction when a program is being executed. This is MAR, memory address register. So in this processor loads the address of memory location with which it wants to perform read and write operation. This is MDR, memory data register. Whenever processor does the communication with the memory for read or write operation, the data brought from memory is stored in this, or data given by the processor to be sent to memory also, it will send through this. Next, this is instruction register. Whenever an instruction word is fetched from memory, that is saved in IR, instruction register. From it is taken to instruction decoder, which decodes and assesses what operation must be done and where are the operands. Accordingly, control logic generates control signals and it will send to different parts of the processor as to perform the needed activities. This is ALU, that is Arithmetic Logic Unit. It can perform arithmetic or logical operations on the operands given on A and B inputs. Which operation must be done, corresponding control signals will be sent by the control logic circuit. The result obtained by ALU is stored in Z register. From here it is sent over the internal bus to general purpose register. So this internal bus is the connecting lines that connects all different parts of the processor. And here we have external bus that connects memory with the processor, and also IO devices are connected through external bus to the processor. Okay. So with this prerequisite, we shall go to next part of the topic. We will examine the internal structure and how it performs the task of fetching, decoding and executing instructions of a program. The processor unit, that is called as central processing unit. So what we have understood from this figure and what parts are involved in that, let us next discuss on how they are utilized in execution of an instruction. To execute an instruction, the processor has to perform the following three steps. The first step is fetch the contents of memory location pointed by the program counter. Suppose the instruction is to be loaded into instruction register. Symbolically, this can be written as IR is loaded with the content of memory location. That square bracket indicates content of PC, that is program counter. Program counter stores the address of memory location where instruction is stored. Hence, content of PC means PC pointed memory location content. That is the instruction stored in the memory pointed by program counter that is loaded in instruction register. That is the first step. Then second step, assuming that the memory is byte addressable, increment the contents of the PC by 4, that is. So after the first instruction is loaded, then PC is incremented by 4 so that PC can point to next memory location where next instruction is stored. The third step is carry out the action specified by the instruction in the IR. So that first instruction which was loaded in instruction register, so in that instruction what operations are specified, that has to be carried out. In case where an instruction occupies more than one word, steps 1 and 2 means fetching the instruction from memory into the IR and advancing the program counter content to as to point to next memory location. These two actions must be repeated as many times as necessary to fetch the complete instruction. These two steps are usually referred to as fetch phase. So next, step 3 phase constitutes the execution phase. Okay. So from this what we come to know, that in execution of an instruction there are two phases, fetch phase and execute phase. In fetch phase, the instruction from memory that is brought to instruction register of the processor. For this, the program counter content is used. Program counter has the memory address of the instruction. After loading that instruction into instruction register, program counter content is advanced by 4 so that it can point to next instruction. If instruction is of multiple bytes, so these two steps are repeatedly continued so that multiple bytes of the instructions are loaded into the IR. So after fetching the instruction is over, execution of the instruction is done. Means what operation is specified in the instruction and what operands are specified, on those operands the specified action is done. This is what is execution of instruction with two phases. Okay. So to execute these two phases, how the internal parts are connected and how they perform the actions, that we shall discuss in the next part. So that is internal organization of the processor, that is different parts what we came to know about the processor, how they are connected and how they operate. So internal bus connects ALU and all registers. External bus connects processor, memory and IO devices. So MAR connects the address lines with the internal bus. MDR connects the data lines in the external bus with the internal bus. Okay. Data may be loaded into MDR either from external memory bus or internal processor bus. So if this is MDR, memory data register, it can be loaded from internal bus or from external bus from the memory. Hence MDR has two inputs. The data stored in MDR may be placed either on internal bus or on external bus. The input of MAR connected to the internal bus and the output is connected to external bus. So input of MAR is connected to internal bus. Here incoming arrow line is there. So hence input of memory address register MAR is connected to internal bus and output of that is connected to address lines in the external memory bus. The control lines of the memory bus are connected to instruction decoder and control logic block. This instruction decoder and control logic block is responsible for issuing the control signals to all the different parts of the processor to control the operation of all the units inside the processor and for interacting with the memory bus. Okay. R0 through Rn-1. So these are the general purpose registers whose number may vary from processor to processor. The general purpose registers are used for temporary storage during execution of some instructions. The multiplexer selects either the output of register Y or a constant value. So either register Y or constant value to be provided as input A to the ALU. This constant 4 is used to increment the contents of program counter PC. That is, if PC is holding the address 1000, so that 1000 memory location, if it is having some instruction that is given to processor, means that is loaded in IR, then PC has to point to next memory location address, that is 1004. For that, 1000 is given to B input of the ALU, and here constant 4 is through mux it is selected and it is sent as A to the ALU. Both are added as per the control signal given by control logic. So 1000 plus 4, 1004 comes through Z register and internal bus it is sent to PC. That is how program counter is made to point to next instruction address in the memory. The instruction decoder and control logic unit is responsible for implementing the actions specified by the instruction loaded in the IR register. Means what instruction is brought in the IR register, that is instruction register. The instruction decoder when decodes that, so which operations must be done and where are the operands, they are specified by this unit. So the decoder generates control signals. Okay, this decoder generates control signals needed to select the registers involved, means which all registers are required. It will select them and it will direct the transfer of data among them. The registers, the ALU and the interconnecting bus are collectively referred as data path. So the registers, ALU and the interconnecting bus, these are collectively referred to as data path. Okay, so with all the parts and their interconnection, that is data path. To execute the instructions, which all operations are needed in different sequence, that we shall see next. So with few exceptions, an instruction can be executed by performing one or more of the following operations in some specified sequence. Means the operations needed to execute an instructions are as follows, and they can be utilized in some specified sequence. That is, first one, transfer a word of data from one processor register to another or to ALU. So the operation regarding transfer of data between registers or between register and ALU, so that is needed. Second one, perform an arithmetic or a logic operation to store the result in processor register. So ALU will perform logical or arithmetic operation and that result will be stored in processor register. This kind of operation is the second one. Then the third one is to fetch the contents of given memory location and load them into processor register. So in memory location there may be data or instruction that must be loaded into processor register. Then fourth one, store a word of data from processor register into a given memory location. Okay, so the processor, whatever result it has generated, so that has to be sent to memory. So to store a word of data from processor register into given memory location, that operation is needed. So these operations in some specified sequence, they are to be performed as to execute an instruction. Okay, we shall discuss how register transfers do take place. That is, the data is copied from one register to another register. So there are two operations that can be done with the register. Data can be put into register, or whatever data is stored into register, that can be taken out. For this, two control signals are needed. So RIN is the control signal that is used to put the data into register from the internal bus of the processor. This is RI in, this is RI out. RI out signal is required to take out the content from the register and put on to processor bus. Okay, so Ri in and Ri out are the two control signals needed to operate that register. When Ri in is set to 1, the data is put into register. When Ri out is set to 1, the content of register Ri is taken out and placed on the bus. So when Ri out is equal to 0, the bus can be used for transferring the data from other registers. Okay. So this is what is input and output gating for registers. Input and output gating for registers means providing the control signals Ri in and Ri out to the register, where Ri in control signal will make the data be copied into register and Ri out control signal makes the data content of the register taken out and put on the processor internal bus. This is what is called as register transfer or input output gating for the registers. Okay. Suppose that we wish to transfer the contents of register R1 to register R4. That is, the instruction is move R1 comma R4. That is, the content of register R1 is copied to R4. Then what control signals are to be used? So the content of R1 is to be copied to R4. So R1 has to give out the data. So R1 out control signal is needed. That is first one. That is to be inputted to R4. Hence R4 in is the another control signal. So move R1 comma R4 or transfer the content of register R1 to R4, which is accomplished by R1 out and R4 in control signals. So enable the output of register R1 by setting R1 out to 1. Okay. So any register if you take, this is just magnified here, any register. So if you take R1, it has to give out because the content of R1 has to be copied to R4. So R1 out control signal has to be given to R1. Next, another such if you consider where R4 is there, so that content is to be copied into R4. Then R4 in control signal has to be activated. That is what is the gating of R1 and R4 registers with the control signals R1 out and R4 in, so that register content of R1 is copied to register R4. Okay. So after seeing two register transfers and input output gating for the registers, we shall see to how in the arithmetic logical operation does take place. That is performing an arithmetic or logical operation. So now let us discuss on how arithmetic or logical operations are performed in the processor. So for that we need these two diagrams. Already we have got introduced to these. That is first one, single bus organization of data path inside a processor. That is ALU and different registers, how they are connected through internal bus of the processor, that is data path. Then we have already discussed on input output gating for the registers. That is, if in a register if it has a data has to be copied, or from register a data has to be taken on to processor bus. So what control signals are needed? That is Ri in and Ri out. How? By making them logic 1, data can be inputted into register from processor bus, or data can be taken out from the register onto processor bus. These two we have already discussed. Next, how actually the arithmetic or logical operation does take place inside the processor, that we shall discuss. Arithmetic logical unit is a combinational circuit, means it is made up of gates. It doesn't have any memory elements. Okay. So it is given one operand from the mux. Another operand is directly given from the internal processor bus. The result generated by ALU is stored in temporary register Z. The sequence of operations to add the contents of register R1 to that of register R2 and store the result in register R3. Means the instruction given is add R1, R2, R3. Add means do the addition. R1, R2 means R1 and R2 are added by the processor. R3 is the destination. Hence add R1, R2, R3 adds the content of register R1 and R2 and keeps the result in R3. For this, the needed sequence of operations are given here. They are in the form of control signals. Now we shall explain the steps involved in giving these control signals. So as to execute the instruction add R1, R2, R3. So add is an addition instruction. We are discussing how arithmetic or logical operation is performed inside a processor. For that we have taken an arithmetic related an example instruction, that is add R1, R2, R3. So the content of R1 and R2 are added and the result is kept in R3. For that the needed control signals in what steps they have given here, that is shown here 1, 2, 3. Right? Now we shall discuss on this. So the steps, the first step is R1 out, Y in. The second step is R2 out, select Y, add Z in. The third step of control signals is Z out, R3 in. So why they are called as the steps? Because in one clock cycle, what set of control signals are given, that forms one step. First step of control signals R1 out. R1 register will give its content onto processor internal bus. Then Y in will take into Y register. So R1 will be stored in Y in the first step of control signals. In the next step of control signals R2 out. So R2 will give its content on processor internal bus. So when R2 comes on processor internal bus, it will be available as B input to ALU. Next, select Y means what R1 was stored in Y register, that will be sent as A operand to ALU. Now R1 is at A and R2 is at B input of ALU. The next control signal in second step is add. Both are added. R1 and R2, which are at A and B input of ALU, they are added. So next Z in control signal is there in the second step only. So what result is obtained by ALU, that is inputted to Z register. In the third control step, Z out. So result which was there in Z register, Z out means it is put onto processor bus. R3 in means that is copied to R3 register. This is how R1 plus R2 both are added and the result is stored in R3. This is how an arithmetic operation does take place inside the processor. Okay. So that completes the discussion on how an arithmetic or logical operation takes place inside the processor. So that is the completion of whole of the discussion on basic processing unit. So what all we discussed in this basic processing unit? The data path inside the processor, internal organization of the processor, and what different 4 kind of operations are needed in specified sequence for executing an instruction, how register transfers take place and what is the meaning of input and output gating for registers and why they are required, how move R1, R4 instruction is executed. With that example, input and output gating for the registers is explained in detail. Next, how an arithmetic or logical operation takes place inside the processor. For that, with the diagram of data path inside the processor and input output gating for registers, explanation is given for this. Next, as an example for arithmetic operation and to explain how it takes place, example taken is add R1, R2, R3 and how that is performed. That completes the whole discussion. I hope you understood. Thank you.